Good morning students, we have been discussing the chapter Parabola in which 3D exercise is going on, and the first two Romans we have completed. Yesterday third Roman, first Roman also we have completed. This is the second question in which he is telling from an external point P, tangents are drawn to the parabola y square equals to 4ax, and these tangents makes angle theta 1, theta 2 with its axis such that cot theta 1 plus cot theta 2 is a constant d. Then show that all such P lie on a horizontal line. So this is a parabola. Next, so from an external point draw two tangents. Draw two tangents. So this is from external point P x1 comma y1. So this tangent is making an angle theta 1, and this tangent makes an angle theta 2 with its axis such that cot theta 1 plus cot theta 2 is a constant. Solution: let P x1 comma y1 be a point on the required locus. So the equation of a tangent in its slope form is y is equals to mx plus a by m. So this implies y is equals to m square x plus a by m. Therefore m square x minus my plus a equals to 0. Since P x1 y1 lies on m square x minus my plus a equals to 0. These are the tangents, and P lies on the tangent, implies m square x1 minus m y1 plus a equals to 0. So this is the quadratic equation in M. Let m1 comma m2 be the slopes of these tangents. Then sum of the roots m1 plus m2 is equals to minus of minus, so y1 by x1 a square x plus by plus c equals to 0 minus b by a, sum of the roots, and product of the roots m1 m2 is equals to c by a by x1. So here m1 is nothing but slope is equals to tan inclination, tan theta 1 plus tan theta 2 is equals to y1 by x1, and tan theta 1 into tan theta 2 is equals to a by x1. Now consider cot theta 1 plus cot theta 2. This is equals to cot theta 1 can be written as 1 by tan theta 1 plus 1 by tan theta 2. This is equals to tan theta 1 plus tan theta 2 by tan theta 1 into tan theta 2. Tan theta 1 plus tan theta 2 is y1 by x1 by this is a by x1. So this is equals to y1 by a, and this cot theta 1 plus cot theta 2 is equals to how much is given? A constant d. So from this y1 equals to AD. Therefore the locus of P x1 y1 is y equals to AD. So which is a horizontal line. Therefore all such P lie on a horizontal line. Show that the common tangents to the circle 2x square plus 2y square equals to a square and the parabola y square equals to 4ax intersects at the focus of the parabola y square equals to minus 4ax. So what is the focus of this parabola? Minus a comma 0. So that point of intersection of the tangents, if we solve, then we should get a minus a comma 0, which is the focus of this parabola. Given parabola is y square equals to 4ax. Given circle is 2x square plus 2y square equals to a square. From this, x square plus y square is equals to a square by 2. So this is the standard form of the circle whose center is at the origin, and radius is equals to r square equals to a square by 2, r equals to a by root 2. So center C is equals to 0, 0 and radius r is equals to a by root 2. Now let the equation of parabola in its slope form is y is equals to mx plus a by m. So from this, m square x plus a by m is equals to y. Therefore m square x minus my plus a is equals to 0. So this tangent also touches the circle. How do we know? Because this is also the common tangent of the circle. That means this tangent also touches the circle. So what is the condition for a line to touch the circle? R equals to D. R is the radius of the circle and D is the perpendicular distance from the center of the circle to the line that we get. So that implies R equals to D. So radius is equals to a by root 2 is equals to, what is the perpendicular distance from the center of the circle to this line? So that is modulus of m square into 0 minus m into 0 plus a by square root of square of the quotient of x plus square of the quotient of y, m square whole square m power 4 plus minus m square, that is plus m square, minus m whole square, that is plus m square. This is equals to a gets cancelled, root m power 4 plus m square is equals to root 2. Cross multiplication, squaring on both sides, that is equals to m power 4 plus m square is equals to 2 or minus 2 is equals to 0. M power 4 plus 2m square minus m square minus 2 equals to 0. M square into m square plus 2 minus 1 into m square plus 2 equals to 0. M square plus 2 into m square minus 1 equals to 0. Therefore, m square plus 2 equals to 0, m square is equals to minus 2. Therefore, m is equals to square root of minus 2 is not possible. Therefore, m square minus 1 equals to 0. Therefore, m is equals to plus or minus 1. Substituting m equals to plus or minus 1 in this equation. Y is equals to mx plus a by m. That is equals to y is equals to m is plus or minus x plus a by plus or minus x. So this is equals to plus or minus x plus a, y equals to. So what are the two equations that we are getting? Y is equals to x plus a and y is equals to minus x minus a. So this is x minus y plus a equals to 0. This is x plus y plus a equals to 0. So these are the two tangents, and the point of intersection of these tangents can be get through solving these two simultaneous linear equations. Solving x minus y plus a equals to 0 and x plus y plus a equals to 0. So subtracting 2x, a plus a is 2a, this is equals to minus 2a. Therefore, x is equals to minus a. Substituting x in any one of this equation, x plus y plus a equals to 0, minus a plus y plus a equals to 0. Therefore, y equals to 0. Therefore, the point of intersection of the tangents. Therefore, the point of intersection of the tangents is minus a comma 0. The point of intersection of the tangents is minus a comma 0, which is a focus of the parabola y square equals to minus 4ax. The sum of the ordinates of 2 points on y square equals to 4x is equal to the sum of the ordinates of 2 other points on the same curve. Show that the chord joining the first 2 points is parallel to the chord joining the other points. So let us take the parabola y square equals to 4x like this, and so let PT1 comma QT2 be the 2 point, and RT3 and ST4 are other 2 points on the same parabola y square equals to 4ax. So let PT1 comma QT2 be the 2 points of a chord PQ, and RT3 comma ST4 be the 2 other points of another chord. another chord. Where PT1 is equals to 8T1 square comma 2AT1, QT2 is equals to 8T2 square comma 2AT2, RT3 8T3 square comma 2AT3, ST4 is equals to 8T4 square comma 2AT4. Let us take the parametric points now. Equation of the chord joining 2 points P comma Q is 2 points form. Y minus Y1 equals to Y2 minus Y1 by X2 minus X1 into X minus X1. This implies Y minus, this is X1 Y1 and this is X2 Y2. So Y minus 2AT1 is equals to Y2 minus Y1 2AT2 minus 2AT1 by X2 minus X1 8T2 square minus 8T1 square into X minus X1 X minus 8T1 square. This is equals to Y minus 2AT1 is equals to 2A into T2 minus T1 by A into T2 square minus T1 square into X minus 8T1 square. So A gets cancelled. So Y minus 2AT1 is equals to 2 into T2 minus T1 by, this is A square minus B square, A plus B into A minus B. So this is T2 minus T1 into T2 plus T1 into X minus 8T1 square. So T2 minus T1, T2 minus T1 gets cancelled. Therefore we get a Y into T1 plus T2, Y into T1 plus T2 is equals to 2X minus 2AT1 T2. This is what we get. So Y into T1 plus T2 minus 2A T1 T2 minus 2A T1 T2 minus 2A T1 square. This is 2X minus 2A T1 square. Minus 2A T1 square on LHS and RHS gets cancelled. Here minus 2A T1 T2. This is plus 2A T1 T2 we got. So therefore this is equals to Y is equals to 2X by T1 plus T2 plus 2A T1 T2 by T1 plus T2. So this is the form. Y is equals to mx plus c. Therefore the slope of PQ is how much? 2 by T1 plus T2. Similarly the slope of RS is equals to 2 by T3 plus T4 will get. Let us take the slope of PQB M1 and the slope of RSB M2. And what is the condition given? The sum of the ordinates. Ordinates means y coordinates on y square equals to 4x is equals to the sum of the ordinates of other 2 points. So P is AT1 square comma 2AT1 is what we get. Take and AT2 square comma 2AT2. The first 2 points are this. The sum of the ordinates. So given condition is the sum of the ordinates, that means 2AT1 plus 2AT2 is equals to the sum of the ordinates of other 2 points. Other 2 points are RS. their sum is their sum of the ordinates is 2a t3, because this we have taken it to be a t3 square comma 2a t3 parametric point. This is a t4 square comma 2a t4. The sum of their ordinates is 2a t3 plus 2a t4. This is equals to, if I take 2a in common and cancel throughout the equation, we will get t1 plus t2 is equals to t3 plus t4. Without loss of generality, I'll do 2 by t1 plus t2 by is equals to 2 by t3 plus t4. Without loss of generality, can we do this? No. If you carefully observe, what is 2 by t1 plus t2 that we got earlier? m1. And what is this? m2. That means the slope of this m1 and the slope of this, which is m2, if two slopes are equal, they are parallel to each other. Therefore, PQ is parallel to RS is what we need to prove. Is parallel to the chord joining the other 2 points. So PQ is parallel to RS. If a normal chord, a point T on the parabola y square equals to 4x subtends a right angle at a vertex, then prove that T equals to plus or minus root 2. So this is the parabola. Now let us suppose that at this point this is a tangent, for example. Then at P, this is a tangent at P. So the line passing through P and perpendicular to this tangent is this normal. So this is the normal. Let's take this point P of T, the parametric point a t square comma 2at. So if this is a tangent, the line which is passing through P and perpendicular to this tangent is this normal. Let this normal again intersects the parabola y square equals to 4x at Q T1, which is equals to a t1 square comma 2a t1. Now this normal chord subtends a right angle at a vertex. So for the parabola y square equals to 4x, what is the vertex? 0, 0, standard form of the parabola, whose vertex is at the origin. So this is a, this chord makes an angle 90 degrees. This chord makes an angle 90 degrees at the vertex of the parabola. So what is the vertex? 0, 0. So this is given, this is 90 degrees. Then we need to prove that T is equals to plus or minus root 2. Solution. Given parabola is y square equals to 4ax. Let P T is equals to at square comma 2at be a point on the parabola. Since P is a normal, let this normal cuts the parabola again at Q T1 is equals to a t1 square comma 2a t1. Now equation of the normal at PT is y plus xt is equals to 2at plus at cube. The equation of the normal at t. Since this normal is passing through qt1, that implies in the place of y substitute 2at1. 2at1 plus x is at1 square. at1 square into t is equals to 2at plus at cube. This is 2a t1 minus t plus at t1 square minus t square equals to 0. This is equals to 2a into t1 minus t plus at. This is t1 square minus t square is t1 plus t into t1 minus t. This is equals to 0. So this is, take a into t1 minus t as a common, then this is 2 plus t into t1 plus t equals to 0. So either a into t1 minus t equals to 0 or this is equals to 0. This cannot be equals to 0 because t1 equals to t, but t and t1 are distinct points which constitutes a chord. Therefore 2 plus t into t1 plus t equals to 0. From this 2 plus t1 plus t square equals to 0. From this t1 equals to minus 2 minus t square. Therefore t1 equals to minus 2 by t minus t square by t is 1 by minus t. T square by t is minus t. Given that this normal chord subtends a right angle at the vertex. So given that angle PAQ is equals to 90 degrees. That means PA is perpendicular to QA. PA is perpendicular to QA. So that means slope of PA into slope of QA is equals to minus 1. Product of the slopes is equals to minus 1 when two lines are perpendicular. That implies slope of PA into slope of QA is equals to minus 1. Slope of PA is 280 minus 0 by at square minus 0 into 281 minus 0 by at1 square minus 0 is equals to minus 1. This is equals to 280 minus 0. So this is 280 into 281. 2 2s are 4a square t1 by at square into at1 square. A into a square t1 whole square. T square t1 square is t1 whole square is equals to minus 1. So a square gets cancelled. T1 this is cancelled. So this is equals to 4 by t1 is equals to minus 1. This implies 4 is equals to minus t1 minus t into the value of t1 is this minus 2 by t minus t. This is equals to minus into minus plus t into 2 by t is 2. T gets cancelled. Minus into minus plus t into t square is equals to 4. So 4 minus 2 is equals to t square. Therefore, t is equals to plus or minus root 2 is what we need to show.